Hey guys, so welcome back to another video. Today I'm going to be talking about improper integrals. And so there's going to be two cases of improper integrals. The first case is the divergent case, and the second case is the conversion case. So first off, for the divergent case, so what an improper integral refers to is if we want to take the integral of something that goes to infinity, right? So for example, let's say I had this graph right here, right? So I want to find the area under this curve. The area under the curve is going to be all of this area right here, right? And it's going to keep going on forever, right? So as my x value gets bigger, my y value is also getting bigger because the curve is growing, right? So when I think about it, it's like, okay, well then what are my bounds? I want the total area for the whole thing, right? I'm going to start at 0, right? Because that's where my graph starts. And then I'm going to keep going until I get to the end. Well, there is no end to this function, right? So I'm going to keep going until I hit infinity, right? So this is what an improper integral looks like. Now, this is why we call it the divergent case. Consider, like, let's say I have a box and I have an automatic counter. So I put something in the box, the counter goes up, right? So in this case, I have a box, my counter is going to be area. I'm going to keep putting areas into the box, right? So first, let's say I'm going to take this area first, I'm going to put it in the box. Then I'm going to take the area from here to here, put that in the box, so on and so forth, right? So notice how those areas, they get bigger and bigger and bigger, right? The graph is growing. So I'm getting bigger and bigger and bigger. I'm putting bigger and bigger integrals inside the box. So that means my counter is going to reflect that. It's going to, the total area that I have is going to keep growing and growing and growing. Well, that means as I keep putting in areas, the total area is just going to get bigger and bigger and bigger. I'm not going to reach a number, right? So in this case, we call it divergent because this limit or this area doesn't exist because it's just going to keep growing and growing, right? So this is the divergent case. So what we care more about is the convergent case, because the convergent case we can actually do things with, right? And so let's say I had a graph that looks something like this, where it goes like this, right? And so I want to find the area under the curve, and so that's going to be all of this area down here, right? And so same deal. This will be f of x. I want to do the same thing. I want to start my integral. I want to go from 0 to infinity, right? And so now when I consider this integral, I'm going to have my box again. I'm going to start putting in areas. I'm going to start with very large areas, right? Because notice how this graph spikes like very close to 0. It spikes all the way at the top. So I'm going to have large area first, and then I'm going to put in smaller and smaller and smaller areas, right? So if I'm putting in smaller and smaller areas, at some point my counter isn't even going to register that I've put in such a small amount of area, right? So this area is so small that it doesn't even change the total area, right? So that means at some point I'm going to reach a value, right? At some point I'll be putting in so many small areas that it won't even change the total area that I have on my counter. So in this case, the way that we would solve for this is, okay, let's say that I'm going to let a replace infinity. If I let a replace infinity, what I'm going to get is I'm going to change this. So I'm going to take the limit as a approaches infinity of the definite integral of 0 to a f of x dx, right? And this is nice because a is something I can work with. A is a variable, right? I can do a squared plus 5, whereas before I had from 0 to infinity, I can't work with infinity, right? I can't do infinity squared plus 5, right? That doesn't make any sense. So here I have something I can work with. I can compute this definite integral, and then I'm going to take the limit. So anyways, that's it for me. I hope you guys learned something. I hope you guys stay safe out there. So yeah, thank you for watching.